Good morning, everyone. My name is voraphan from Tokyo University of Technology. So today we are honored to present our research, the interactive environment mediated nudging. In our daily life, we observe that people violate the public manner in the public spaces. For example, when people are using smartphone while they are walking, it reduces their situational awareness. And another scenario for the current situation of the COVID-19 pandemic situation, the people often unaware about to have a safe distance. So the conventional media, such for the voice announcement or the signage, seem not effective enough to attract people's attention. And also there need some deliberate engagement, such for the command or operate. So in our motivation, we propose to design the stimulus that seamlessly integrate in the real living environment, that so this system so ubiquitous and less noticeable. And the second, to use the proposed system to investigate the human behavioral response, to observe how effective our approach is. And third, to create a new type of interaction between the digital function and the people using the nudge, that it doesn't require people intentional interaction. So our concept, we in our research, we borrow the theory of the nudge. So the nudge theory is the proposed method for the reinforcement or indirect suggestion to impact or influence the desired behavior. For example, in the figure above left, using the nudge to guide the people to lead them to the desired ways, using the text that have like to invoke their instinctive action, that so that people can go to the desired way. And the nudge now is being developed and widely applying in the digital environment, so-called digital nudge. So digital nudge, for example, they use in the UX and UI environment, such for the design that can influence their decision making on choice, that they call the digital nudge. However, the existing this research or the limited using the digital nudge and nudge theory in the only in the digital sphere. So our aim, we propose that using the nudge theory and digital functionality to enhance the real world or apply in the physical environment. So the purpose of the nudge based on the HCI, they categorize the nudge in 4 categories based on 2 variable mode. The first one for the reflective mind and the automatic mind, which is for the mode of thinking, how people think about the nudge, that design. And another variable is non-transparent and a transparent, which is the to show whether the user can perceive the intention of the nudge, that design behind. So in this study, our nudge is in between to prompt reflective, such for our design stimulus, and to influence the behavior, such for our design the environmental change. So here is one of our design scenario. So we decide the scenario for the specific situation as one of our core idea. So for example, we situate the situation for nudging a person to practice a social distancing during the COVID-19 pandemic situation. So first, envision that people is sitting together while they are not unaware about to have a social distancing. So here, the nudge can be applied. So we design such a digital sound stimulus that can create the psychologically effect that impact the a person instinctive action, such for using the mimicking phenomenon of the mosquito buzzing that can arouse the instinctive action of the person. So as for our design intervention strategy of the stimulus, we assume that when people perceive the mimicking of the mosquito buzzing envision around them, the people might feel anxiety and fear. And also our system, we install we use the directional speaker that can deliver to the person in the center only, that doesn't affect the people on the both side using our digital technique. So here, this design sound stimulus can act as a nudge, and that can impact a person instinctive action, such for they engage and adjust themselves in the social distancing unintentionally. So this is one of our example. And here, to make it happen, we use the hardware design using the 4 directional speaker, and also we control by one Arduino Uno. And we collect the sound data using the MP3 module board for 4 units for each one of the speaker, and collect this and call the sound data by using the GUI interface. So we are using the capacitive sensor to activate all the system that we place in the center position. And for the right side, for the hardware design, we try to create some kind of bench to place in the real environment, in the general bench. So we create some kind of capacitive sensor, be like using the aluminum foil and the rubber sheet attached on the top and the bottom, so that when people sit in the defined position, the system would be activated. And for the software control, using the GUI that can create the sound sequences, and also the order of each speaker that using the deliver the sound. And also on the right side, for the working order, we first the input the data as people place on the sensor, and then the data feed to the software interface and Arduino, and then the sound device sound sent to each multi-channel speaker, and then the sound would be emit. And here is our design sound pattern that's based on the cognitive of emotion that can impact the anxiety and fear. So we create the 3 parameters for the left side figure as to arouse their emotion of anxiety and fear, using the 3 individual parameters, such for the sound sources, frequency or the time, and the volume. So first, the sound sources. Firstly, we initially do the preliminary experiment for selecting the sound source using the to invoke them. So using the mosquito buzzing sound, and the monster roar sound, and the siren sound, and the people scream. So for the experimental scenario, the people answer for the 5 Likert scale. They indicate that show the most buzzing sound can invoke them the most, and they feel anxiety and fear. So we chose this sound source to be used in our approach. And also the sequences or timing based on the theory of the rhythmic that can produce in alternating low and high, or on and off. So also the rhythmic sound can produce they can create the produce process of the rhythmic, that the meaning can be assigned. So we try to imitate the mosquito buzzing surrounded the participant using the buzzing sound. So we then we do the experiment so that the participant tend to be perceived the rate higher than 500 millisecond for the frequency that. So we use the 3 different rate of the frequency. And then the volume, we know that increase the volume can invoke or prompt the people respond. So we also use the decibel rate from the human hearing from the 0 to above. So here how we create the desired sound pattern. And for the left side, the desired sound audio effect, we propose the 3D sound using the multi-channel speaker install surrounded the participant that focus on the people on the center, that the system doesn't affect the people on the both side by we examining the suitable position from 0 degree, 225, 180, yeah, and 135. So in this setting is created for the specific situation. So here is a design sound of the 3D sound. And then the prototype demonstration. So we created 4 multi-channel speaker using in the specific situation, and we decide the position of speaker. Here the sound. Oh yes. So here is a 3D audio effects that we propose. Yes. So and then for the performance evaluation, we examine the accuracy rate for the 4 channel of the speaker. So if they can produce the audio output by using the GR control. So the threshold the sound, when the sound emission within each period of the rhythm, we consider to be accurate. So for overview, that the result indicate that the system work fine, and as they can produce the sound sequences and the define rhythmic sound. But however, we need to improve the accuracy rate or improve the prototype function, such for the this device is not automatically adjust itself to the physically of the individual that need to be automatically deliver the sound. So we will discuss in the next section. And here is an experimental scenario. We imitate situate a group of people that sitting together while they are unaware of the safe distance and needed to adhere of the COVID-19 prevention. So first, the experimental condition, we install the 4 directional speakers surrounded the participant, and we prepare the people on the both side beforehand to sit. And this experimental scenario we propose to use in the outdoor environment where it's open to the surrounding. And for the left side, for the A is a proposed method of the 3D directional sound using the condition of the mosquito buzzing, and B and C using the traditional audio effects or the non-3D sound using the condition of the mosquito buzzing as a mimic sound and the conventional siren sound. So as the result, the participants tend to perceive the proposed mimic 3D audio effects that's superior to the traditional audio effects using the warning sound. So we observe that using the proposed directional 3D sound effect is the most effective to prompt the participant in social distance scenario, as most of them get up from the bench. So our threshold when people on the seat from the center get up from the 2 seconds, we just to be nudged according to the user rate reaction of the audio. So here for the discussion, for the performance evaluation, show that the mechanism work fine as it can produce the rhythmic sound and the sequences of the sound. And the second prototype, the proposed approach and the user study. So the result indicate the proposed directional 3D effects can prompt a person to observe their surrounding context. And also the design of the sound stimulation induced a person instinctive action desire in the specific situation. So this design stimulus can act as a nudge and root out the person behavior such that they unintentionally adjust themselves in the social distancing. However, in contrast, the participants tend to have a less response when the traditional audio effects or the conventional warning sound was used. So we suspect that the participants are familiar with and understand the meaning of the simple warning sound, which is limited to arouse them. So, and for the proposed approach, the reviewer raised the question that how our approach can use in the border situation, such for the supermarket, department store, and the train station or the park. So here we categorize our experiment into categories to solve this issue. So we divided into part is a indoor environment and the outdoor environment. So from the preliminary experiment in the indoor environment, the sound system is create the echo, which is affect or disrupt the intention of the desired sound of the nudge. And in the proposed outdoor environment that we examine, the sound has less reflection and doesn't affect the intention of our design. So here, our approach is designed not to be the universal, but for the specific situation as one of our example in the core idea. So if we try, the system should be designed according to the circumstances. And the third, to the interaction design of the system, as the reviewer raised the question. So in generally, the seating position is not exactly correct. So how we deal with the result against this issue. So we answer that in our experiment, we use the bench as a mark on the position so that the participant can sit in the correct position. However, in the real environment, we suspect that the result can be slightly changed according to there is no the mark position, but we assume that the system can be work as for the general bench has limited for 2 or 3 people, that the system can be decorated.
Okay.